Now alpha beta are the roots of the equation x squared plus px plus q is equal to 0. Therefore alpha plus beta will be equal to say minus p, and alpha beta is equal to say q there. Also it's the roots of this equation x power 2n plus p power n x power n plus q power n equal to 0. Alpha is a root of this equation. Therefore alpha to the power of 2n plus b power n alpha to the power of n plus q to the power of n equal to 0. Beta x also is a root of this equation. Beta to the power of 2n plus p power n into beta to the power of n plus q power n equal to 0. Once you arrive at this result, the temptation for me to subtract this because q power n can get cancelled there. So alpha power 2n minus beta power 2n plus p power n into alpha power n say minus beta power n equal to 0. This is equal to alpha power n plus beta power n in the alpha power n minus beta power n. Therefore if I take alpha power n minus beta power n outside, I will be having alpha power n plus beta power n plus p power n equal to 0. Or in other words, alpha power n plus beta power n will be equal to minus p to the power of n. Say alpha beta are the roots of this equation, alpha by beta, and of course beta by alpha is the roots of the equation x power n plus 1 plus x plus 1 power n equal to 0. Alpha by beta is the root of this equation, alpha to the power of n by beta to the power of n plus 1 plus alpha by beta plus 1 to the power of n is equal to 0. That is alpha to the power of n plus beta to the power of n. Here plus alpha plus beta to the power of n equal to 0. I remove this common denominator beta to the power of n. This is nothing but minus p power n we have proved, plus that will be equal to minus p to the power of n. This is equal to 0. And this can happen only if n is an even integer. If it is an even integer, this will be a negative term which get cancelled. This will be a positive term which will get cancelled with this, and hence n must be say an even integer. Our choice 2 is correct.